Коллеги, друзья, здравствуйте. Очень рад вас здесь приветствовать в этом зале. Давайте поприветствуем друг друга. Конференция только-только начинается. Меня зовут Антон Черноусов, я девелопер-адвокат в Яндекс.Клауд, и сегодня я буду вашим ведущим здесь, на этой сцене. У нас сегодня длинное, огромное путешествие, и сейчас на сцену, вот в это длинное путешествие, я хотел бы пригласить первого спикера, и надо было бы его как-то представить, но он так долго в разработке распределенных систем, что я даже не знаю, как по-другому его представить. Филлип Делgyado, поприветствуем на сцене. Филлип – огромный авторитет в нашей области. Филлип, тебе слово.
Привет. Так, мне дальше слышно. Меня зовут Phillip Delgyado. Я в основном занимаюсь финтехом, уже лет 15 пишу всякие платежные системы. Там делал довольно много разных платежных систем России. Сейчас делаем карточный процессинг нового поколения. Но рассказывать я сегодня буду вообще не про финтех. Сегодня я буду рассказывать про распределенные системы, потому что все мои системы за последние годы получаются распределенными. Ну, обычно это называется микросервисная архитектура, но у самого слова микросервисная архитектура на самом деле содержания особенного нету. Но так, кликер не работает. Кликер что-то не работает.
Секунду.
Из доклада сбросился на первый слайд.
Сейчас. Подожди, а пока мы, собственно говоря, решаем технический вопрос, микросервисная архитектура, казалось бы, что это такое? Что это за безобразие?
Ну, на самом деле, собственно, про это был первый слайд, что никакого определения формального микросервисной архитектуры нету, что есть примерно из десяток разнообразных, там один у Ньюмана, другой у Фаулера, третий у Ричардсона, четвертый у Ричардса, и все они написали про разное. То есть...
Что когда мы с вами, вот мы сейчас у людей спросим, и они будут у каждого разные, в каждой отдельной компании одни или другие. Ну, и в одних комьюнити одни, а в других другие. А поднимите, пожалуйста, руки, кто в каком-нибудь комьюнити состоит. Поднимите руки, пожалуйста. Так немного, то есть все как бы вот по своим норкам сидят. Кстати, хочу напомнить, что сегодняшнее наше мероприятие проводится при поддержке огромного комьюнити PosiDev. Здесь вот есть у нас QR-код, так что, в общем, можно к нему присоединяться. У вас есть прекрасная возможность это сделать. А мы сейчас ждем перезапуска нашей презентации. Как только она запустится, можно будет продолжить. И вот вернемся, если к определению.
Ну да, у кого вообще, вот поднимите руки, у кого микросервисы в компании, в продукте? Мне очень интересно, те, у кого их нету. Ну, потом расскажите, а что у вас происходит. А кто понимает разницу между микросервисами, сервис-ориентированной архитектурой, pipes and filters? У кого-нибудь pipes and filters вообще в продакшене есть?
Давай я тоже подниму руку, потому что у меня тоже было. Это не стыдно, поднимайте руки, если что.
Да, вот. Может, мне без слайдов начать читать? В конце концов, там все не так сложно.
Филлип, ты настолько прекрасен, жги.
Вот, да. Ну и, собственно, я в качестве основного определения последние годы люблю определение Фаулера про то, что микросервисы — это про независимые элементы деплоя, живущие в разных процессах, которые при этом общаются через легковесные механизмы. И, собственно, это вот общение, взаимодействие через легковесные механизмы обычно и вызывает существенные проблемы. Ну, а какой вообще механизм для взаимодействия? Там использовать... Поехала. Да. Собственно, вот, да. И, собственно, вот это вот прекрасное определение Фаулера, которое я нежно люблю, одно из самых вменяемых, потому что компактное. Ну и возникает вопрос, а какие механизмы? То есть мы можем взять HTTP, gRPC, можем вообще через базу данных сделать взаимодействие, через какой-нибудь SharedDB или DBQ, или Kafka поставить. И, собственно, сегодня мы будем в первую очередь обсуждать именно, какие варианты сценариев взаимодействия бывают, когда что имеет смысл использовать и где и какие подводные камни встречаются. Ну, собственно, примерно вот такой у нас будет план рассказа. Мы разделяем три основных сценария. Это информационные запросы, где мы просто хотим что-то знать. Это то, что мы хотели, чтобы кто-нибудь сделал. И события, когда информация о том, что что-то произошло. Мы будем пытаться понять, какие из этого есть выводы, в чем эти сценарии отличаются. Ну, начнем с самого простого. то, что называется во всех старых книжках синхронный обмен. Обычно имеется в виду HTTP. То есть у нас есть какой-то поток, мы в нем вызвали другой сервис, ждем на этом потоке, когда этот сервис нам ответит, и дальше идем. Все вроде бы замечательно, но такого в реальности уже давным-давно нету. То есть во всех современных языках, если вы кого-то вызвали, ждать ничего не надо. У вас там либо крутины, либо гарутины, либо какая-нибудь акторная модель, либо, в конце концов, реактивное программирование. То есть никакого блокировки ресурсов на процессе вызова HTTP сейчас на самом деле нету. Поэтому никакой особой синхронности в синхронном обмене в современных реальностях нет. Но традиционно все пытаются использовать слово «синхронный обмен», и мы дальше будем тоже его понимать как обмен по HTTP gRPC, когда мы в среднем ждем ответа, желательно в том же самом инстансе или в том же самом потоке исполнения. А что такое синхронный обмен? Ну вот, не знаю, у нас там стоит какой-нибудь RabbitMQ кролик без durability, без репликаций и в режиме request-response. Это синхронный обмен или асинхронный? Или стоит Kafka, но вроде бы Kafka уже совсем асинхронный. Мы будем дальше, когда говорим про асинхронный обмен, говорить вообще про все варианты несинхронного обмена пачкой. От кролика, от ZeroMQ, в общем, от UDP это все будет считаться асинхронично.
So UDP,
Но как микросервис
it would all be considered as micro, which is not actually true, but well, micro has never been micro, and synchronous exchange has never been exactly synchronous. So we don't want only this synchronization. And we will really use the standard HTTP or RabbitMQ and so on. So this is without the state storage or with the state storage like Kafka, RabbitMQ plus durability, DBQ, and so on. So, of course, we can have orthogonal states with or without the storage of the state. But let's look at the simplest way. What is BFF? BFF is a standard pattern of SQL-based systems, is backend for frontend. It's a proxy in the interests of a specific client representing the entire system. For example, if you have some layer between the client and the system is BFF. You can Google actually the words that you don't understand in my slides. It's the simplest way and the most useful. So the client needs to go into three services like clients, balances of accounts, for example, from the accounting service, and their credit limit from the credits service. So the simplest way to release all this information is HTTP. So we have called these three services, collected the data, and released the data to the client. HTTP is an old way because we have addresses of servers in the configuration and we have asked the queries and are patiently waiting for responses. 10, 15 years ago, people did everything like this. Now we have a mesh service in between. So who knows what a mesh service is? Okay. In fact, this is just one of a lot of options: API gateway, word balance, or service mesh, whatever. There is very little difference between these go-betweens. I will use mesh as a universal word to describe any go-between between BFF and services. So, for example, mesh finds out where client service lives, on which port, which IP, and so on. And then it actually routes the query. Meshes, for example, know that a service has ended responding, terminated responding. It can balance the load as well. There are a lot of other functionalities. We will talk about them later. So this is a scheme of asynchronous queries. We need to understand how reliable this system is and what the risks are. The worst option is generating an error. We cannot route this response. or untimely response. For synchronous systems, more than 100 milliseconds is too much. 100 milliseconds is not exactly synchronous. 25 milliseconds would be okay. So a normal way of response would be 5 milliseconds between two services. Mesh takes about 1 millisecond. So this part can be completed in 18 milliseconds. So far, so good. But if one of our services is dead, what happens? Even though HTTP is described as a synchronous protocol, of course it is not synchronous. It is based on IP, and the IP is Internet Protocol, is asynchronous protocol. So we know what we know. We have sent a query and we have not received a timely response. What is timely, as far as I understand, by default timely is 30 milliseconds. You can set it up to 1 millisecond, but I think I don't know of any synchronous responses less than 1 millisecond. You cannot even have settings in libraries. So if something has, if some service is dead, we will know that within 1 second, and this is not a timely response to the client because our response time would be more than 1,000 milliseconds. Okay, if Mesh knows that some service is dead and it routes the query to another one. Okay, so the old copy of the service is dead. Now you get the response from the new copy of the service. The real time of response will be 18 milliseconds, not 1,000. So this is why Mesh is important. It knows that a service does not work. So, and the better this go-between works, the higher chance you have to provide a timely response. Of course, it doesn't mean that nothing else can happen, because in reality, the average response time is really average. Here, for example, you have latency by percentile distribution for RabbitMQ. But it's what's important here is that if you look at every hundredth, thousandth, and so on response, you will see that for some responses, so 99% of responses come back in 5 milliseconds, and 1 in 100 comes in 100 milliseconds, 1 in 1,000 comes in 1,000 milliseconds. So while on average everything looks okay, in reality, some responses will not be routed back to the client because, well, or they will not be routed back in a timely manner. They will come back in 1 second, 2 or 3, and so on. So it's important to have an average time quick, but you need to look at percentiles, at percentile distribution as well, because if your percentile distribution goes up peaks at 300 milliseconds, it's not good. So protocols without states are easier to describe as synchronous. I know people who do data enrichment with synchronous protocols. I don't know why, and I'll be very interested to find out why you, for example, well, offline, of course, why you, for example, use Kafka to do your data enrichment, because I don't know why it is necessary. So without storing states, that's better. You would need backup copies of services. You need a go-between in order to switch over to a new copy or a working copy of the service, and it's better when a go-between does that. You need a heartbeat, and graceful shutdown. Heartbeat is you know when your service is dead, and graceful shutdown, for example, is when your service gracefully tells you that it wants to die. But it does not die all of a sudden, but first it processes all the incoming queries, then it says no more queries please, and only then it dies. Of course, graceful shutdown is a great functionality for service reliability, and you will never have ideal reliability because we live in the real world. Now, let's look at commands. The standard thing is to authorize a payment. For example, we want to block some amount of money. And it's important to understand whether we have blocked the money or not. You really need a response whether your command has been executed or not. So if this is a quick command, it's okay. But if it takes 50 milliseconds or 500 milliseconds, if, for example, you need to query an external system that takes 10 seconds to answer, of course, this is not a synchronous system after all. And again, you want to do a Kafka or a Rabbit like a queue. So we have put this command in a queue, and we reliably will get an answer, or if we don't get an answer, we don't need it after all. And if we have a good queue, you can balance load between the accounting services, for example, if there are more than one. We can avoid parallelism and blockings, for example, if all the data on a specific account will be on one partition and they will be processed sequentially. One of the uses of Kafka is just about this, and we will talk about that later. Now, what of reliability? Let's go back to this description of quote-unquote synchronous. When are we going to get problems? The problem is that we have sent an event. While this event is executed, the service has shut down, and the producer does not resend the command because it doesn't know that the service shut down. So what is MTBF? Is mean time between failures. For hardware, it would be, 50,000 hours between failures. And it's also important to know what FFT is. It's the feasible failure. It actually tells you how many times you want to resend your query, how quickly do you need a response, whether your query has been executed or not. So this is this formula describes your annual probability of getting a problem. For example, if we have a normal mesh and it tells you whether you have a problem not within 1 second, and your MTBF is 55,000 hours. So once in a billion years, we will lose all commands in 2 seconds. You would think that not in my lifetime, but this is in an ideal world. But for example, if we have an OOM failure once in the end of the day, and our MTBF is 1 day, and your FFT is 30 seconds, that means that once every 6 years, we will lose all commands within 30 seconds. But if you have 10 consuming services and 10 producing services, you need to multiply it by 100. Okay, the mathematics is a little more intricate there, but if you have 10 versus 10 and one of them shutdowns once a day, you will get a probability of having a problem in production once every month. If you have 1,000 services and all talk to all others regularly, so you have to multiply by 1,000,000, and of course this formula will be much less pleasant for you. You need to keep this formula in mind when you make a decision what kind of SLA you will be comfortable with. For that, you will need to calculate your FFT, your MTBF, and then you start a mitigation. Let's compare this with Kafka, for example. Kafka needs a lot of brokers, right? There are at least 5 brokers in Kafka. So the probability of more than one services to shut down is much higher, because a broker may shut down, and when a broker shuts down, the commands just don't travel. And if you have one Kafka with 1,000 services, it turns out to be more reliable than direct communication. Who does not understand what I have just said? Okay, everybody knows what the theory of probability is. But very, very few people who really work with the systems from my chat history actually understands that 200 services are much less reliable than 2 services. So, what do we want to make sure our commands are executed or we find out about problem? First of all, timeouts. The smaller the FFT, the more narrow the FFT window, the less likely your command is going to get to your consumer. And you need to use a smart mesh or broker. It's not just to know that you have a failure, but for example, you may need to know that with a normal 5 milliseconds timeout, your real timeout is already 20 milliseconds, and therefore you need to refrain from sending others. So there are some meshes like this, but you have to set them up. You can create a specific mesh balancers API gateway, which will know that we are running out of memory, running out of resources, and avoiding overloading a specific layer for a time being. The smaller the number of services, the more reliable you are. If you have 5 monoliths and they direct communicate over HTTP, it's much more reliable than them communicating through a go-between. Smart shutdown is also very important. For example, we do not accept any more incoming HTTP connections, and we just shut down. This is not very reasonable, because if you have a Kafka, and if you want to restart a service, you shut down the application with Kafka. Kafka closes down all consumers, the consumers will be redistributed, Kafka will have to raise another application, and that will take a lot of time. So maybe you should not allow Kafka to redistribute consumers among services, because you know you will raise up in another 5 seconds and you will execute the entire queue. So very few people work with Kafka, because I suspect that this is kind of a black magic to everybody else. It's a big theme how to set up Kafka in the right way. Please go to Kafka presentations. There are few such presentations on RabbitMQ. RabbitMQ is even more complicated, but there are very few presentations like this. But there are certain presentations on Kafka. I'm trying to show you the complexities of a seemingly simple thing, sending a command and getting the notification whether this command was executed. So brokers and what they do are the cornerstone of reliability of your system. So the more reliable your broker is, the more reliable your overall system is. These are not all issues with commands. If you look at producer versus consumer, they are interdependent. It is a two-way street. You can't change the format of the command on producer without changing a consumer, because your consumer cannot get the data from nowhere if the producer does not provide the data. So again, this is a two-way street. This is a logical connection, and it is impossible to break this bond. HTTP, Kafka, Rabbit, whatever the protocol is, and this dependency is visible when you change a contract, but the visible part of the contract is a tip of the iceberg. Compared to the overall content of the contract. In HighLoad, I will have a special presentation on what the contracts of the services are and how to take account of them and so on. And one of the great examples is when my servers started to work 10 times faster, and that had led to shutdown. Because before, the old logic actually relied on the fact that if we query several services, we will have time to process everything. One of the services started to work faster. The system actually started to produce old data without having processed the new incoming. So this connection is very, very deep. Please keep that in mind. If you have a mesh as a go-between, the dependency becomes visible. So you call a point. It has parameters. If you need another tree point, you add other parameters. We can do something canary deployment. Who knows what canary deployment is? A lot of people. So you can do a lot of versions of the same entry point and so on. But if we have asynchronous exchange, that's more challenging because this dependency becomes invisible. Someone writes into a topic, someone reads from a topic, and you actually cannot see that directly in the broker's logs, whose messages were routed where, and so on. And it cannot be seen even in the network settings. And versioning becomes much more challenging because you have a problem what you do with old events, with events that were pertaining to the older systems, and the autonomy of the services stands in the way because you cannot release a new producer because you need to wait for all the consumers to process everything and shut down, and you need to do a lot of other things. I will talk about them in about 6 weeks. And if you have a general queue, you have a dependency of producer on what comes from the consumer. You need, for example, a partitioning key. And the partitioning key is filled by the producer, but in fact, it's knowledge of how the consumer prefers its data to be balanced. It's not a contract-based dependency. It's a realization-based dependency. And every time you talk through a common queue, formation from producer, and that's bad because that affects the autonomy, isolation, and now what to do about this? The only thing that we need for asynchronous is put if we tell the consumer, it's your own queue, the service knows how to put the event into a queue, balance it, and how to process it, and so on. Maybe if the format is not okay, the queuer, the go-between, will tell us that the format is wrong. Versioning is of course much better when the consumer has the intermediary and the queue. You can raise 20 different versions. This is called pattern box, transaction inbox, and it improves the consumer's autonomy. It kind of makes for a lighter dependency between the producer and consumer. So what is transaction outbox? Who knows what is transaction outbox? It's the same thing, but on the producer side. We don't send an event right away because we want to make a transaction. We want to know that it goes at least all the way to the broker. We put it on a local queue. A scheduler takes it from the queue and sends it where you want it to be sent. If you have a broker, we have a transaction guarantee that you will at least send something to an external service.
Вы все равно положили и куда-то отправили. Гарантия
If you have put it on a queue, at least you have the guarantee that it will go out of the outbox. So
И вместе они дают довольно дорогую, но очень
together, transaction inbox and transaction outbox
Здесь у вас, конечно, сильно влияет это на производительность, потому что
create
там
a
какой-то нагрузка на
system
IO, там база данных.
which is a little bit expensive, but very, very reliable.
Связка будет наиболее надежной.
So this is the most reliable with the biggest amount of guarantees, and of course it will take a lot of resources. Of course, you can use a common broker, but you will need to save resources and resolve issues.
Которые здесь указаны на доске. И вся наша текущая реализация
All our current implementations says that we should work at least once. Each message should be processed several times. We deliver it once, it can be processed several times. Exactly once delivery. We send at least one message. It can be processed several times. So, if you have at least once, you should be able to repeat your commands, your instructions. If the first event was erroneous, so you can repeat it in the right way. It's not an easy thing to do. You can use natural keys like phone number, if it is the same phone number that you know, so you support it. But such unique keys are not numerous, and the phone number is not unique, as you know. One person can have several phone numbers. One phone number can belong to several people. So we generate artificial keys. You generate a key, send the key, you check it. If you already have such key, then you say, no, this key cannot work, generate another one. As a result, you can have billions of keys in several years. Do not store all the keys indefinitely. You must be protected against repetitions for about 15 minutes, but 2 days is enough. But technically, 15 minutes is okay. Then, if you have a partitioning balance, each service depends only on the customers with headers that were addressed to those particular people. When the service is delivered, you can take all events for the previous 15 minutes and take the keys only, store them in memory. If the key is repeated, you may say, sorry, we already have this key. So 15 minutes is all right. Of course, there will be some little delay at the start, but you shouldn't, in that case, keep a huge database. The probability of transaction repetition is low. If the customer complains, we can return his money. This may be the best thing in that case. Once a month, once a year, it will be cheaper. Well, we have to be able to calculate probabilities inside the service using different patterns. All the interesting things takes place with services.
Поговорим про события.
Let's talk about events. This is the first slide where we collected data from several services to transfer them. In another case, we don't go to any services. We have some actual data provided by the services. We take the data and deliver aggregated information wherever necessary. We get the data, put it in a certain cache, which lives for a certain period of time. This is good for microservice architecture. Each microservice is autonomous. It publishes all the changes. It subscribes to external events. It keeps all the data inside. It has a huge cache. Moreover, if you look at it, about 2/3 of microservice courses recommend such a scheme. Let's look at it attentively. What are the main problems? Even if two services interact, they become interdependent. All the services here depend on each other. If one of them wants to get a new field or change the structure of input data, anti-fraud wants to know not one telephone number, but all phone numbers of that customer historically. In that case, you have to change accounting, you have to change analytics, because the format of interaction is different, which makes the system much more complicated. You have to know at any moment of time all the consumers of your message, although you broadcast them, but still you should know who receives your messages. Event should be received if the customer is a terrorist. If you don't know that, then you will have a problem. The event should be processed. Even if when the event is not processed, legal event, you will have problems. Any event should be regarded as instructions. And all transaction, inbox transaction, outbox, guarantees, everything should be applied. Because instruction events are a bit different from the modeling point of view, but from the point of view of implementation, they are much similar. There are some rare cases when you don't care if the event reaches the destination or not. If in a week's time you see the problem, you will return the money to the customer, and that is all right. But you have to assess the risk yourself. You have to take a decision whether you need such a complicated system of verification or not. What can pops up be replaced with? Well, if you have 3 services, they need data, you provide the necessary data, and you control the situation. How to orchestrate it, it's a different question. I like durable execution, temporal. Do you know that? Temporal error. Well, if you don't know, it's good for orchestration. If you... Oh, what's the name? Temporal, what was the initial? Cadence. It was called Cadence, then it became an open source project. It's one of the most interesting and elegant solutions for distributed orchestration. I described them when I talked about reliability of such systems. Distributed systems, or you can take something else if you like, and all the dependencies are obvious and open. You know what kind of data is expected. It's a clear contract.
Конкретный контакт двух конкретных.
It's a clear contract between two services, and it's very easy to
Собственно,
manage
потому что у нас реально в IT есть
it.
ровно две проблемы, как известно.
So there are two problems: validation
И
of
обычно,
cache
когда
and
возникает во всем много
naming.
проблемы, и инвентаризация
Usually you have
новых
two,
законов все-таки большей части
both of
проблемы.
them. But I'm going to talk about the
Ну и
first
дальше про
one,
события и про
cache
команды.
validation. What about
К
events and
сожалению,
instructions?
у нас
Unfortunately,
реально есть всегда что-нибудь может произойти
in
не так.
reality,
Админ может взять и
something
снести
can go wrong.
карту за последние, со всеми данными, которые еще не успели дойти до потребителя. Просто потому, что
All
Kafka
the data
данной
can be
компании
lost in
отдельным службам
Kafka
доставки. Я знаю такую
because
компанию.
Kafka is
У нас
regarded
может быть
as
напутать,
unreliable
опять-таки,
by
там
many
ops при
companies.
выкладке и забыть подписать получателю
Ops
на
can
пакет
forget about
новый токен, который ему
signature.
нужен. Мы можем напутаться в форматах обработки
We
и потерять
can
данные. То есть всегда
mix
бывают
the
проблемы.
formats.
И
Always
поэтому
you
нам
can
на
have
самом
some
деле недостаточно
human
просто
errors
послать
and
событие в
problems.
команду сервис
So
сервис
you
Б. Нам надо
shouldn't
как-то
just
проверять, что вообще было все
send
хорошо.
the message
Это
from
называется
service
умным
A
дом
to service
реконсиляция.
B.
И для нее есть много
You
паттернов и ни одного
need
идеального. Ну,
reconciliation.
самый простой вариант не просто отдавать события
The
любые данные,
simple
а показывать версию.
solution
Отдаете
is
клиенту и говорите,
to
что
show the
это версия
version.
клиента, срез номер 4.
This
Ну и
version, one
получатель говорит,
slice
ага,
4.
ко мне пришла версия 4, а у меня сейчас актуальная 5. Явно что-то не то
Yes,
произошло,
the
надо
actual
ругнуться.
one
Или ко
should
мне
be
пришла версия
5,
4, а
says
я
the
вообще ждал,
customer.
а у меня предыдущая 2. Куда девалась третья?
I had slice 2.
Сообщить
This is
проблемы,
slice
а не
4. Where
разобрать.
is
Это самый
slice
простой
3?
вариант, самый дешевый, уже
So
позволяющий обнаружить какие-то проблемы.
it's a red flag.
Можно пойти чуть дальше, например,
You
хранить
can
на
go
клиенте
further.
или
You
на
can
потребителе, на
store
клиенте, на отправителя
at the
счетчик,
customer,
например,
at
сколько
the
событий было за
destination, at
последние
the
сутки.
sender,
Ну и дальше
the
сверять. Раз
number of
сутки я
events, the
отправил
counter
1000,
of events. I
999,
sent
наверное, что-то не так.
1000.
Это дает возможность поймать
The
гораздо большее
customer
количество
received
проблем. Возможно, потому
999.
что кто-то
Oh,
что-то не
one is
подписал,
missing.
кто-то
You
что-то
can
удалили, что-то потеряли, что-то неправильно
detect
обработали.
all the
Ну и третий
missing
способ,
things.
когда мы поднимаем
And the
отдельный
third
сервис,
one,
который так обычно
when you
называется
have a
сервис
separate
консайлер,
service,
который собирает с какой-то регулярностью все данные с
reconciler,
продюсера и с
which
консюмера и
collects
выясняет, что у них
all the
одинаковое
data from
представление о
producer
реальности.
and
Если
consumer
в продюсере
and
у клиента
sees
есть
that
такой-то номер
everything is
телефона, то у
synchronous,
консюмера тоже
everything
точно
is
такой же номер телефона.
balanced,
Это на порядок
the
более
phone
дорогое
number
решение,
is the same.
но оно
It's
единственное
more
более-менее надежное. Вся финансовая
complex,
схема
it's
работает
more
через такой вот
expensive, but it's
реконсиляцию. То есть
much
вы
more
отправляете платежи,
reliable.
они быстро
You send
проводятся, а
the
потом все равно
payments, the
отчет обо всех
payments
этих
go
платежах идет от
to
одного
the
контрагента к
customer,
другому,
and
и они раз
then
в сутки
you
сверяют,
get
отправили ли мы все
reconciliation
почтой, а
and
не
check it
произошла ли какая-нибудь
once
фигня.
every
Ну и дальше
24 hours
включается
if everything
противоправный
is
процесс,
correct. And then
что
you
произойдет,
switch
если
on
они
other
почему-то не совпали, эти
processes.
данные.
What happens if
Ну,
data
если у вас есть
doesn't
реконсиляция,
match?
возникает
If you
вопрос,
have
что делать, если мы какую-то
reconciliation,
проблему
what
обнаружили. Поэтому
should
нужно
you do if you
изолировать
do
историю,
have a
когда
problem?
мы повторяем
So
все свои события
you
с
have
какого-то
to
времени. Там отправляем
repeat
заново все то, что нам
all
нужно,
the
либо,
events
может быть, только изменившись за какое-то последнее время.
once
И реально,
again.
если мы хотим делать какие-то надежные
If
системы,
you
нам
need
нужно
a
реализовать
reliable
реконсиляцию
system,
или стриминг,
you have
и
to
все эти
have
паттерны, которые мы говорили о
reconciliation,
взаимодействиях, либо
second
осознанно отказываться
streaming,
от них. Мы считаем,
or
что мы не
reject
будем делать
them if you
реконсиляцию,
have to
потому что
take
нам клиенты
the
позвонят
risk.
и сами
For
позовутся, и мы
example,
с этим
we don't need
разберемся. Ну,
reconciliation
нормальный
because
подход.
we are
Непопулярный,
ready to
финансово
return the
оценить.
money to the
Понятно, что
customer.
дешевле негодование клиентов,
So
нежели
you
реальная
have to
реализация.
evaluate the risk
Ну и в
and the
заключение.
cost. And to
Мы вообще
conclude,
оставили за кадром много других тем. Мы там
we
ничего не поговорили про
missed many
архитектуру
other
pipes and
things,
filters, который тоже есть
like
агент событий,
architecture
нераспределенный,
of
но вообще
pipes and
другой.
filters.
Мы не поговорили про то, как
We
можно
skipped
делать всякие workflow, что может быть, кроме темпового
workflows,
и мы не поговорили про
and
события
we
вокруг
didn't
хореографии,
talk about
оркестрации и почему они не имеют никакого значения, на
orchestration.
самом деле, физического. И на самом деле зря вообще придуманы и используются. Нам попытаемся подвести все равно итоги того, что мы обсудили.
But still,
Ну,
let
во-первых,
us
надо понимать, что все взаимодействия разные, все брокеры
conclude.
разные. И
All
Kafka,
interactions are
RDB,
different.
Vue какой-нибудь,
Kafka,
там, Istio,
Rabbit,
Traffic. У них у всех
Istio,
разные гарантии,
Traffic,
разные
they have
возможности реакции на
different
проблемы,
guarantees,
разные
different
паттерны
warranties,
использования. И
different
вы не можете
reactions,
один на другой
different
взять и
usage
легко поменять,
practice,
как бы вам ни
and you
хотелось.
cannot
Они
replace
все
one
немножко
with the
разные.
other
И когда вы
because
будете
they
эти
are
темы
all a
понимать,
bit
какой именно
different, and you
брокер,
have
какой именно
to realize
поведение
what kind of
и как
broker,
именно
what
вы его
kind of
используете.
system you
Две
choose
простых
and
задачи.
use. There are no simple tasks. We talked about reliability. There is also security. Security in Kafka should prevent data from being stored in the disk. So you have to encrypt everything, exchange keys. It's not a trivial task. But unfortunately, I have to do it from time to time. You have to encrypt, you have to provide reliability. Then there are no simple solutions here when you choose the type of interaction, the type of microservice, or just add a new feature. All vendors are wrong, all books become old age, and when you read books, when you listen to vendors, when you take data from different sources, then you will have a true picture of reality. And the best thing is to take it and check yourself. I use JSON and HTTP because it's faster in all the platforms. Parsing of JSON has the best speed. For the teams, I like to use the entire process, JSON, inbox, outbox, to simplify interaction between services. For events, I prefer orchestration. We have a library for that. External reconciliation and restreaming on demand. Reduce interaction. The less interaction, the simpler the system. Monolithic systems are not in fashion now, but you can use hierarchy of services. Not all the services are the same, and you have to split your big product between domains. Like Cuber. Use all the analysis. Actually, object-oriented analysis is all about objects in the small talk paradigm. And all the object-oriented analysis is about reducing the number of interactions. And the theory of systems, of course. Sometimes it's better to use a couple of books. Simplify interactions. Try to be laconic. Don't try to build a huge enterprise database. It should be as simple as possible and as fast as possible. Isolate complexities. Let complexity be inside your services, not in your communication channels. Complexities should be in your infrastructure. Use technologies for the purpose that it was created for. MQ, for example, is for queuing. Don't use it for transport. HTTP is a tool for hypertext systems. Don't build IP on it. And so on and so forth. After this event, no one will eliminate Kafka and choose HTTP, because people are always irrational in their choices. But if you want to optimize something, you can find useful ideas in my report. Thank you for attention. There is a QR code.
Супер, спасибо тебе большое за
All
выступление.
right.
Поднимайте
Thank you very
руки.
much
У
for
нас
your
есть
event.
специальные
Please raise
девушки и
your
мальчики,
hands. We
которые
have
будут с микрофонами
people
подходить.
here with the
Так, я вижу,
microphones. They will
вот
come
здесь
to
молодой
you.
человек первый будет.
Yes,
Второй вопрос
please. You
вот
are
сюда,
the
вот
first.
первый
The
ряд,
second
пожалуйста.
one is
Молодой
here
человек,
in
представьтесь,
row
пожалуйста,
one.
откуда вы и
So,
вопрос.
what's your name? Where are you from? Dmitry Kuchko. Thank you very much for your presentation. It was very interesting and it was well structured. The question is like this. In the end, you said that you use outbox, inbox, and what is inside as a bearer, as a carrier? What kind of bearers?
Именно у нас в компании, собственно, из компании
In our company, Electron, everything is complicated. One of the bases is Foundation DB, and it is our main database. We use Kafka as a broker because it is efficient in positioning to avoid data blocking. So between subdomains we have Kafka, transaction inbox outbox is with DB. Foundation DB is a key value database, distributed database with good ACID. Jepson Test said, oh, why do I need testing? They tested better than I. More hands, please. Yes, here, and then a young man over there.
Микрофончик можно вот молодому человеку?
Microphone right there. Thank you. Just in case, I am here until 6 p.m. Please come to me and ask your questions for the whole day. Your question, please. Who are you?
Зовут меня Олег Жулин.
I am Oleg Zhulin from FinTech IQ. My question is, first, thank you for your presentation. It was very interesting. And the question is a simple and a complex one. You said, you spoke about Kafka and security. Without encryption in producer and consumer, how can we authorize in topics? How can we split data between who needs them and who doesn't need? In Kafka, there is a standard customer authorization mechanism. It's not a simple one, but it exists, but it doesn't eliminate problems. We send data, and unfortunately, Kafka cannot encrypt them on disks. So we have to do it ourselves. Otherwise, any person who takes the disk out of the rack can just read it. It's not a good approach. It's better to encrypt at the application level. I love application level encryption because you can support many keys, key management, and other administrative functions when we encrypt.
Так, давайте, значит, вот сейчас молодой человек вот здесь.
Right there.
И вот
And
сюда вот потом
then
микрофончик вот в серой...
after that here, in the great dress. Thank you for your presentation. You had a slide with service where you said proposed a counter at producer and consumer. If you have a counter, how do you react if you see data mismatch? Or you react only later when you find this mismatch? How fast do you react? I didn't see such solutions if you have data mismatch and we do something at once. Usually we detect it later in the process of monitoring, and then restreaming is used. Yes. TCP/IP is like that. So it's TCP/IP on top of Kafka, to tell you the truth. Then, of course, the counter and a lot of other parameters of TCP/IP stack can be analyzed a bit later. When event was not sent, when there is no confirmation, it's a good protocol on a bad transport. Reconciliation tells you there is a mismatch and you have to do something later. Where are you from? Raise your hands if you have more questions. Evgeny Karpov, Alpha Bank. I'm not a developer, but what I noticed when you talk about guaranteeing data delivery, you missed one thing which is used with plastic cards. When one data payment is split into several processes. Yes, it's not an interaction point. It's a deep attention requirement. Any operation of this kind can be split into subsequent steps. When we split a transaction into authorization and posting, so first we ask the possibility of payment and then we send confirmation. And you can repeat such instructions many times. Plastic card payment is just splitting the transaction into consecutive steps. I have a lot of reports about financial technologies, but this is not the subject of my presentation today. With plastic cards, you will have huge problems. Sometimes you have only 5 seconds to go. What is the mean time before failure? TCP/IP is about reliable data transfer over non-reliable channels. If you take each your request with confirmation, well, that will be expensive. It will be expensive, of course. The more reliable, the more expensive. So, with card payments, it's always the balance between reliability and cost. It's a separate task. Thank you. Thank you very much. I think you can continue asking and answering backstage. Tomorrow I'll be in Novosibirsk. Today I'm in Moscow. I have the last question in the end. You mentioned a list of tools. It's not complete, but is there any tool or method, an ugly one, which seems to work, but you are reluctant to use it? Have you got such a thing? It seems to be good, but no, I don't know. I really don't know. I personally, it's my personal opinion. Renan and Q. It's my personal. There are some companies that have, I looked at different products and architecture, and I don't know how it works. And Mongo also. Mongo, how it works.